mainly for examination purpose. I have observed that in laboratories that many students are struggling to adjust the CRO or to bring the CRO into correct conditions. Today I am going to make a simple methods what you have to do. So there are different types of CROs are available, different brands, and I am going to show you that how they differ. But a common feature is that there are few controls. It is almost all CROs it is there, like this. So there is a time-based control and attenuator control, channel 1 and channel 2. These are all common for in almost all CROs. Okay, let us start. How to make this CRO for our examination purpose and how to start. Okay students, let us explore the CRO here. I am going to tell you only a simplest method. I don't want to spend much time for this. Examination purpose, how to do this. Okay, so the CRO, I select one scientific model here. Like this, I already shown you that different models of CROs available. So I am going to select this model for this video. So as soon as you connect this CRO to the main supply, first what you have to do is you have to press the main switch. See that LED is glowing. Okay, you have done that. But you observe no trace on it. So what to do? You have to see that whether this brightness control is kept minimum or maximum. This is the first thing you have to do. Okay, let me see that. Let me increase this a certain level, but still there is no trace. So here you need not to worry. The next step, you have to adjust up and down control of the first channel here. See that. This is what you have to do. Okay, if you want 2 channels, then you have to go for the second knob and adjust this. Sometimes even though if you adjust this, you will not get this channel trace, because if you select this dual channel to mono, one channel will disappear. Did you observe that? See that. This is in dual mode, and if you release this key, it is in mono. So keep in this mind that initially when you require only one channel, don't go for dual. When required, then only you have to select. Now if the intensity is maximum, adjust the intensity to a suitable level. See that this is minimum and this is maximum. If you keep this the brightness at maximum, the phosphorus screen on the CRT will get damaged. So adjust it according to your taste. Next control is you have to see that focusing. See, this is out of focus now, and these also out of focus when I keep it minimum. So position it exactly like this. So you understand this, how to do the initial things. So next step, what you have to do in the control panel once you got the trace, this is very important here. See this, there are different keys are available here other than these 3 controls. It is common for almost all. Okay, let us check the CRO probe. Let me tell you what exactly the CRO probe here it is. This part is called as a BNC connector. What is BNC? BNC is nothing but banana connector. So this is a male BNC connector, and on the CRO you can see that a female BNC connector here. So while checking the CRO probes, better always select the first channel like this. Just you plug here and you push it and just turn right side, that means in the clockwise direction, then automatically it will get locked, otherwise you will get the loose connection. Next, in the CRO probe you can see there are two wires are available here like this. One is positive, another is negative. So the first thing is you have to check the positive terminal condition. Both the terminals are important. Anyhow, first we are going to check the positive terminal. So select the positive terminal here, and there is a calibration option. In each and every company has provided that called calibration here. Can you see that? Okay, now you see that you select the positive terminal of this probe and just connect to this 2 volts peak to peak, or you can select 0.2 also. Both are correct, anyone you can select. So I am going to select this 0.2 for explanation purpose. I just connected. Okay, now see on the monitor on this CRO you can see that square waveforms. But what happens, some students, I have observed that even though CRO is working, they are doing a different method of operations. So what they have to do initial stages is, first you have to find out where you want to test, whether it is 0.2 volts or 2 volts, you decide. So for that purpose what you have to do is you have to select a first channel, because you have connected the CRO probe to the first channel, and you have to see that where the position of the volts per division control. Suppose if this position is somewhere here like this, you cannot see that square waveform here. See that it is too small. See, if I select still smaller one, it is difficult to get output. So to avoid this kind of conditions, there is a simple technique is there. First you have to see that which scale you are which calibration point you are going to select here. So for example, if I select 2 volts, then you have to see the ranges available here. See, here it is 20, 10, 5, 2, 1, something like that. Different voltages are available here. What is the voltage here mentioned? You can see that. If I select the 2 volts, you find out whether 2 volts range is available here. Okay, it is available here. You can see that. You can go for 2 volts range or 1 volt range. Select it according to that. It is always better to select 2 or 1. Now you test it. See that the output exactly it will display. Now you can measure the amplitude here. See that, adjust this Y position and position on Y axis somewhere here, and see that there are actually 2 divisions are available here. So 2 into, here the scale we selected 1 volts, you can see that this is 1 volt. So the amplitude will be calculated, number of divisions on Y axis, here it is 2 and the scale we selected is 1, so 2 into 1, 2 volts. So according to calibration it is 2 volts. That means our CRO probe is in working condition. What about negative terminal? If negative terminal is defective, again you will not get output. For that a simple method is short this positive negative terminal to this positive terminal, the CRO probe, that means the square waveform will disappear. See that. Did you observe this? I am just connecting this. See, the output disappears. That means this negative terminal is also in good condition. This is the first work each and everyone has to do. We don't know that the CRO probe is in working condition or not. If you get a new one, that is okay, but it is used regularly by different students. I don't know what happens. So better you do this method. I think you understand that how to check the CRO probe. Okay, let us go for the next step. Okay, Before measuring that different kind of signals on the CRO, measurement of the amplitude, frequency, all these things, you have to understand certain important things. I already introduced some tips in the intro about this. Anyhow, I will give one more simple thing. You see that always select the first channel for your output or input. Only one probe is sufficient. Do not connect, because we have different BNC connector here. I have observed that many students will connect probe 1 here, 2, and if you observe one more probe somewhere here, there also they will insert it. So don't measure. Just select the first channel, connect it to the first channel only, test this probe. If the probe is exactly matching with the calibration, that shows the CRO is calibrated properly. So before that, you have to see that there is important control here. Do not press this key, ground key. Here it is ground key. See what happens when you press this ground key. You see that if you press this, see there is no output. Suppose if you check this probe or signal or output from the circuit diagram, if you see that this is pressed, you will not get any outputs. So be careful. See that all ground connections, AC, DC and mono or dual connections, all press to on, press to off switches only. Most of the products are like this only. See that all the keys are released. This is very important. Let us start the actual measurement of time. From there you can calculate frequency and amplitude measurements. There are very simple techniques I will teach you. How to scale, how to select the scales when you give unknown signal, and how to get it within a fraction of minutes. Okay, let us see. Okay friends, let us start how to measure the signal. For that we need a function generator. Say a probe is connected here to a function generator. There are different types of function generator available from the different manufacturers. In some function generator it will display a frequency, whereas in some manufacturer they will not provide the display for the amplitude adjustments. So in this model we can adjust by seeing the display also. Anyhow, assume that there is no display available here. If that is the case, then how to adjust the CRO and how to measure the unknown value of the signal. So on the CRO there are different applications. You can measure amplitude, time period. From there you can measure frequency. Addition to that you can measure the phase angle, and you can see the Lissajous figures and so on. Here students, particularly in the maximum number of experiments, they are going to measure only the amplitude and frequency they are going to measure. So we will concentrate only on that. I have connected a function generator here, you can see that, but I am not getting output here. Why? Because I pressed the ground key here, so I have to release it. Understand? So the main function of the most of the CROs by mistake, when students are sitting, when they are idle, what they will do, they will press all the keys and they will change the settings. So take care of that. All the keys are released. I am repeatedly telling this because that problems I observe. So now something I got. See, in the function generator I will explain. I will post a separate video on function generators. So time being, I am not going to concentrate on that. I am concentrating only on CROs. So I have connected function generator. I selected a sine wave. So in the function generator there are options are there for sine, square and triangle all these things are there, and there is now control where you can adjust the amplitudes. See that. I will show the panel controls in a separate video, but time being I am going to show only this which we required on CROs, and you can vary the frequency also. See. So in this video I am going to select a sine wave for our purpose, and I am going to adjust this here. I don't know what is the amplitude. How to select this? Which scale I have to select? So what I have to do here is first get the trace by adjusting. If it is the trace is somewhere here, get it down, and you can adjust the first work is to adjust the volts per division control like this. Do not go for this, and that is not a suitable scale, and change it to this. Okay, I am not satisfied with this because I am not able to take the reading. This is okay. At the same time, do not select the least range. I am not able to measure this. I think students also understand this. So select a suitable scale. This is okay. This also okay. Okay, now time being I am going to select this. So what is the scale here? You can see that 0.5 volts. Okay, 0.5 volt scale I have selected, and let us go for that time based control here. See that time based control, I am going to adjust this. See this, what happens. Which time based control you have to select for this, because assume that this is unknown value for you. Suppose if you select this scale, the least value something like this. See the waveform, you can't read the frequency. So what you have to do, keep on exchange this, and finally at one stage this is okay. What is the scale now? Just monitor here. It is 0.1 millisecond. You can see that 0.1 millisecond. What about if I select this, the next range? See the CRO? Okay, that is also good. What about this next scale? No, only one waveform is there. It is difficult to measure all the way. Suppose if I select the scale to maximum level, is it okay? No. So go back and select a suitable range. Okay, this is okay. This is also okay. So time being I am going to select this. Let us measure the amplitude and time period, and we will conclude this video here. Now what you have to do next is to adjust the x-axis position here. You can see that x-axis position here, and see what happens when I adjust this. You can position on x-axis, and left or right or at any moment, at any position you can adjust. At the same time, you can see the first channel y-axis, that is up and down control. You can position anything. I think you understand this. Now I want to measure the time period. Okay, let us measure the amplitude first, because I explained that in the beginning itself. What you have to do is, see, there is a subdivision scales also there on y-axis, and this is called x-axis. You can consider as a reference line this, but it is possible you can consider any lines. We generally will call it as an x-axis. You can consider any one on this. There are different boxes are available here. See, on y-axis there are 1, 2, 3, 4. So there are overall 8 boxes are there. On x-axis there are 10 boxes are there. 1, 2, 3, 4, 5. 5 plus 5, 10. So now let us measure the amplitude. I can position this signal by using first channel up and down control somewhere on any reference line. You can position this here or here or even at the bottom. It is option left to you. So I am going to select on this position. For me, for measuring the amplitude, this will be a reference line. Now slightly I will move this y-axis to this position. Okay, it is now exactly y-axis. Now I am going to measure number of divisions here. 1, 2, 3, 3.5 4. Okay, subdivisions, each subdivision is 0.2, it is 3.4. So 3.4 into, what is the control reading here? 0.5 volts. So multiply these two, you will get the amplitude here. Suppose if you want one particular experiment, 1 volt peak to peak, what you have to do? So assume that it is 1 volt peak to peak you require, any value. See, the best method is to select the scale first. For example, if it is 1 volt peak to peak, so which scale of the volts per division I have to select in the beginning itself? The best way is 1 volt scale input voltage, means if you want to set 1 volt peak, select 1 volt scale here. That is correct. Suppose if you want to, same 1 volt, if you want to make a big wave, then select 0.5, that is also correct. If you select 0.2, not suitable, because we cannot measure the frequency or we cannot align to this. So you better select 0.1 or 0.5. I think you understand this. This is the simplest method. Suppose if I want to select, if I want to measure the 10 volts peak to peak, which scale I have to select? In the volts per division scale, you can select 10 or 5. If I want to measure 0.5 volts, so which scale I have to go? Better not 1. You go for 0.5 here, or 0.2 also you can select. So if that is the case, the amplitude will be something like this, then you can multiply with this. So selecting this lowest range will go, the waveform will go beyond the screen, it is not suitable. So go according to that. I think you understand what I say. I will repeat once again. If your, for example, if your input is 1 volt, you select a scale range of 1 volt or 0.5. If your input voltage or measuring voltage is 10 volts, you select the scale of 10 or 5, like that. I think you understand this. From there you can measure number of divisions which cover from between peak to peak, multiplied with this scale will give you the amplitude. Okay, let us study the measurement of the frequency. See, this is an analog CRO. You cannot measure frequency directly. Whereas nowadays DSOs are available, digital storage oscilloscope, where you can measure directly the frequency it will display. Okay, this is a basic model, and for the beginners, let us see how to measure. Because you cannot measure the frequency directly here, you can measure time base for 1 cycle. So how to make this? So adjust this control and press the ground key and position on, adjust this x-axis and position on this x-axis, release the ground key. Now exactly it is there. Now you adjust this position, the first waveform, say that the wave begins from here to this point. I think you understand this. So how many divisions it covers here? 1, 2. So this is one scale. Okay, that means one waveform, it is one cycle. So the same method can be easily measured, adjusting this, bring it down and adjust the x-axis. Again you measure that the distance between two peaks on x-axis. Again it is 2 divisions. Now these 2 divisions multiplied with time-based control. So the time-based control here is, you can see that it is 2 milliseconds. So here it is 2, here it is 2 milliseconds. So it is 4 millisecond is the time base. Suppose for simple calculation I am going to adjust, so 1 kilohertz. You see that the waveform it is varying there. For simple calculations I will show you 1 kilohertz roughly. You can see that the waveforms it is moving. If you want to adjust to expand this and towards y-axis, adjust this. That means time-based control. or adjust these to position it. You can make it big or small. So many students will understand by mistake they will understand that these controls will set the voltage. Sorry, the CRO will show whatever the input you feed, the same value it will show. It is just like a mirror, that's all. In what costume you are going to appear in front of the mirror will show the same as it is. Don't assume that the CRO will do all this magic. Okay, just it will measure. It is a measuring instrument. But the input can be adjusted from the function generator. Now time being, I want to show you how to measure. See, I adjusted to 1 kilohertz here. Now let us see how to measure the time frequency from here. I already told you cannot measure the frequency directly. So bring it down by adjusting control and x-axis control. You position it like this. Okay. Now you see that it controls 1, 2 divisions and x-axis multiplied with the time-based control. So it is 1. So 1 millisecond. Sorry, 0.5 milliseconds. So 2 into 0.5, it is 1 millisecond. Thereby the frequency is 1 divided by 1 millisecond, nothing but 1 kilohertz frequency. See that? I adjust the frequency to 1 kilohertz. Okay, this is how we are going to adjust the CRO. Hope that this video will help you to do successful adjustment of the CRO. So in the next video we will see that about function generator. Thank you very much.